Hi, my name is Lister Miramontes and I'm here to discuss about the UJT. UJT is also known as Unijunction Transistor. It is mostly used on AC power control applications. So, the UJT consists of three terminal device, namely emitter B2 and B1. UJT have unidirectional conductivity and negative impedance characteristics, acting more like a voltage divider during breakdown. Um, Dito naman yung simplified equivalent circuit ng UJT. So the resistances of these terminals is dictated by the physical position of the PN junction. So ang ibig sabihin lang nun, if yung PN junction mo located is more on located here, kunyari sa B2, ang mangyayari dyan, pinapababa ng PN junction yung resistance ng B2 mo. Mas mababa na ngayon yung resistance ng B2 mo kaysa dun sa resistance ng RB1. Then, these two series resistances produces a voltage divider network between the two base terminals of the UJT. Next naman. Next naman is yung static emitter characteristic curve that shows the relationship between the emitter voltage and the emitter current. Initially, the emitter voltage increases from 0 until it reaches its peak point. Pero bago ma-reach niya yung peak point niya, nagkakaroon muna siya ng slight leakage current from the terminal to the emitter. From the terminal to the emitter, shows na yung curve, nagkakaroon siya ng curve papunta dun sa way nung emitter current. Kaya siya nagkaroon ng curve dyan. Then, so patuloy-tuloy na yung pag-increase nun hanggang sa ma-reach siya na yung peak point. Peak point is the highest emitter voltage and the emitter current. Yun, na-reach siya na yung peak. Then after that, there is a large amount of decrease in emitter voltage and large amount of increase in emitter current. It is mainly due to the negative resistance region. Kaya nangyayari yun. Then after that, tuloy-tuloy na yung pagbaba ng emitter voltage saka emitter current hanggang sa ma-reach niya yung valley point. Kapag na-reach niya yung valley point, ang mangyayari sa device is that it will draw into saturation. So, mag-off ng device. Yun. Then, kung ibabase natin sa graph natin, yung application nito sa mga devices is that yung mga device na pag na-reach niya yung peak voltage at saka peak current niya, daan-daan na siyang mabababa hanggang sa mag-saturate na siya hanggang sa maging off na siya. So, yung applications ng mga devices na ganun is more on triggering devices for SCRs, voltage regulators, and timing circuit.
I'm Mr. Soraya, and I'm going to discuss about the PUT or the programmable unijunction transistor. I'm going to show you first the symbol and the block diagram of the PUT. The PUT is a type of thyristor. It has a 4-layer semiconductor material and a PNPN. It has 3 junctions that is connected to the cathode and the anode. This is the symbol of the PUT. It has an anode, gate, and cathode. Next, I'm gonna show you the characteristics and the biasing of the PUT. Uh, the anode is connected to the voltage, and the gate is connected to the voltage divider of R2 and R1, and the cathode is connected to the ground. The characteristics of the PUT is the plot of the voltage of the anode and the current. As you increase the voltage of the anode until it reaches the voltage peak, the current also increases. And that, and when it reaches the voltage peak, uh, the it cannot increase anymore, and this is called the negative resistance region, where the voltage of the anode decreases and the current of the anode increases until it reaches the point of the valley point, in where the voltage cannot decrease anymore, and it the voltage will increase because it will act as a fully saturated PN junction.
Hello, I am JD Torres, and I am going to talk about Diac. A Diac is a full-wave or bidirectional semiconductor switch that can be turned on both forward and reverse polarity. The Diac came from a word, diode, and AC switch. The Diac is an electronics component that is widely used to assist in triggering of Triac when used in AC switches, and as a result, they are often found in light dimmers such as those found in domestic lightings. These electronics components are widely known for the use in starter circuits for fluorescent lamps. Here is a symbol for a Diac. Diac symbol used to depict this electronic component in circuit diagrams can be remembered as the combination of what may appear to be two diodes in parallel, but connected in opposite directions. Owing to the fact that Diacs are bidirectional devices, the terminals cannot be labeled as anode and cathode as they are for a diode. Instead, they may be labeled as A1 and A2 and MT1 and MT2, where MT stands for main terminal. Here is the characteristic curve for the Diac. Diac circuits use the fact that Diacs only conduct current only after a certain breakdown voltage has been exceeded. When the Diac breakdown voltage occurs, the resistance of the component decreases abruptly, and this leads to a sharp decrease in the voltage drop across the Diac, and a corresponding increase in current. The Diac will remain in its conducting state until the current flow through it drops below a particular value known as the holding current. When the current falls below the holding current, the Diac switches to its high resistance or non-conducting state. Diacs are widely used in AC applications, and it is found that the device is to reset to its non-conducting state each time the voltage of the cycle falls so that the current falls below the holding current. As the behavior of the device is approximately equal to in both directions, it can provide a method of providing equal switching for both halves of the AC cycle. Most Diacs have breakdown voltage of around 30 volts. Although exact specifications depend upon the particular type of device, interestingly, their behavior is somewhat similar to a neon lamp, although they offer a far more precise switch on voltage and thereby provide a far better degree of switching equalization. This is the structure of a Diac. The Diac can be fabricated as either 2-layer or 5-layer structure. In the 3-layer structure, the switching occurs when the junction that is reverse bias experiences reverse breakdown. The 3-layer version of the device is more common and can break over voltage of around 30 volts. Operation almost symmetrical owing to the symmetry of the device. A 5-layer Diac structure is also available. This does not act in quite the same manner, although it produces an IV curve, curve that is similar to the 3-layer version. It can be considered as two breakover diodes connected back to back. Diac applications. One of the major applications of Diac is with Triacs. It is used for conjunction with triacs to equalize their switching characteristic. By equalizing the switching characteristic of these triacs, the level of harmonics generated when switching AC signals can be reduced. That is all for Diacs. Thank you.
Hi, I'm Christian Mark Angelo Canlas, and I am here to discuss the triode AC switch or Triac. So, a Triac is used as a solid-state power switching device and also a bidirectional device. This is the symbol of the Triac. It has two anode terminals and one gate terminal. This is the characteristic curve of the Triac. In quadrant 1, the Triac is usually turned on or triggered into conduction state by the positive gate current, while in the quadrant 3, it is triggered by the negative gate current. This is the holding current and this is the conduction state. For applications of Triac, the Triac is the semiconductor device widely used in power control and switching applications. This is an example of a circuit in which the Triac is used. So, in this circuit, when the switch 1 is open, the Triac will be on off state because there is no gate current that can enter the Triac. But when the switch 1 is closed, the voltage here, the voltage VG will supply the current IG by the use of this resistor to the Triac, and then it will turn on to conduction state, and it will complete the circuit and activate the lock. So that's it. Thank you.